Here we go. So this is the second half, the grade C and B questions from the intermediate numeracy paper from summer 2018. And we're on to question 8, which is an area and volume question. Now it never fails to depress me how bad students are at working with area and volume. No, I'm not just talking about Green Hill, I'm talking about when I'm marking these papers. Really bad. So the concrete base of Miss Morgan's new bungalow is shown below. The concrete base of Miss Morgan's bungalow is 0.2 meters thick. So that's looking from above, and that you can see is how thick it is. Calculate the volume of the concrete base. Now, in order to work out the volume, if we go back to our formula page, you may not think it, but that is the formula that helps you work out the volume. It's the area of the cross section, which is, if you slice it, will always give you the same shape, times the length. Well, the cross section of this is that. So that's my area. Now I need to work out the area of that and then multiply it by how deep the concrete is going to be. And to work out the area of that, what you do is split it into two shapes that you know the measurements of. There's different ways to split the shape. Okay, I've gone for that way, but you could have cut it across that way, or you could have worked out the area of the full rectangle and taken the area of this bit away. Different ways of doing it. So if I call that part A and that part B, the area of A is just a rectangle now, so it's just 5 times 4. So the area of that little bit is 20. Now I've got to work out the area of B using the same length times width method. I know that it's 15 wide, but what I don't know, or it's not telling me, is what the distance is from there to there. But because I know it's 5 from there to there, and they're rectangular, that means it must be 15 going across there. So to work out the area of B, what I've got to do is 15 times 15. It's a non-calculator paper, so you need to have the skill of multiplying two-digit numbers together. So the way that we've been working on that the last few sessions is using the old Chinese method. So I'm going to put 15 like that. Then I'm going to do 5 times 1 is 5. And 5 times 5 is 25. 1 times 1 is 1. 1 times 5 is 5. Then I'm going to add up the diagonals. So I got 5. 5 and 2 is 7. And 5 is 12. 2 down carry 1. And 1 and 1 is 2. So when I multiply that together, I get 225. So to find the total area, I've got to add those two together. So that'll be 225 plus 20, which is 245. And it's not asking you for the units, but it's a good habit to put it in. So that's 245 units of area, square meters, meters squared. Has that answered the question? Nope, because it's volume. I found the area. So in order to work out the volume now, I've got to multiply that by 0.2. Okay, so a bit more space. Volume is the area, 245, times 0.2. Well, if I do 2 times 245, I'm going to get 490. but I haven't got 2. I've got 0.2, so that's going to move the decimal point in 1. So it's actually 49 cubic meters. So another occasion where you need to have that skill on a non-calculator paper. B. Mr. Graham is building a garage. Oh, I haven't done the marks, sorry. Question 8. So for that, you've got a method mark for working out what the area is. And a method mark for multiplying the area by the volume, and then 2 marks for getting the right answer, so for dealing with the 0.2 to get the 49. Part B. Mr. Graham is building a garage. A concrete mixer lorry holds a maximum load of 6 cubic meters of concrete. There's a fixed standard delivery charge of £35 a load, and the concrete costs £45 for every cubic meter. Mr. Graham orders 2/3 of the maximum load of concrete. What is the total cost of Mr. Graham's order? Okay, so I've got to find the cost. In order to find the cost, I need to know how much concrete he's bought. He's bought 2/3 of the maximum load, which is 6. So amount of concrete bought or purchased would be 2/3 of, and of is times 6. Okay, because the maximum load a lorry can carry is 6 cubic meters. If you think back to that question we did where we were dividing to find 2/7 of an area, here we find 1/3 of 6. 1/3 of 6 is 2, so 2/3 will be 4. So he's buying 4 cubic meters of concrete. Each cubic meter is going to cost him 45 quid. So cost of concrete will be 45 times 4. Double it, 90. Double it again, 180. Is the total cost 180? Let's go back. Have I used every bit of information? A concrete mixer holds a maximum of 6. There is a fixed standard delivery of £35. Have I used that at all yet? No. So I've worked out the cost of the concrete, but I haven't added on the standing charge. So the total cost will be 180 plus the £35 standing charge. So that's going to end up as £215. Marks for that. 1 mark for working out the 2/3 of 6. And an answer mark for that, and then 1 mark for working out the cost and adding on to get the 215. Question 9. Done this one in class this week. Olga took out a high interest loan for £400. She paid back £49 a month for 20 months to clear the loan. Calculate the total interest that Olga paid as a percentage of the original loan. So the first thing we need to do is work out actually how much she paid in interest. So she borrowed £400 and she's repaying £49 for 20 months. So the total repayments is £49 a month for 20 months. So if I double 49, I get 98, and I've got a 0 on the end. So although she only borrowed £400, she's actually repaying a total of 980. So the total interest that she's paid would be the difference between what she's paid back and what she actually borrowed. So she's paid £580 in interest. Now what the question's asking is calculate the total interest as a percentage of the original loan. So to turn it into a percentage of the original loan, we've got to work that out of what she actually borrowed. So we would do 580 out of 400 times 100 to turn it into a percent. 580 times 100 is going to be 580 with an additional 2 zeros out of 400. I can divide by 10 and I can divide by 10 again. I can keep cancelling zeros until I run out. So what I then end up with is 580 over 4, which then is a division. 4 goes into 5 once, remainder 1. 4 goes into 18 4 times, is 16, remainder 2. 4 goes into 20 5 times. So the interest rate is 145%. So there's 2 marks just for working out the 980, even if you couldn't do anything with the percentages. There's 1 mark for the maths as a percentage of the original loan. So the original loan goes on the bottom, and then 1 mark for the 145%. Question 10, bearings. Sarah is carrying out a survey of the 3 villages, Cwm, Alltir and Gwyndir. The diagram below shows the positions of the 3 villages. So Cwm, Alltir, Gwyndir. What's important here is these words. It's not drawn to scale. So although it's a bearings question, we can't measure the angles. So with a bearings question where you can't measure the angles, that needs to trigger for you parallel lines. Because everywhere where there's a north and a south, those lines are parallel. So this is actually a parallel lines question as well as bearings. If that said drawn to scale, we could measure it, but it's not. What is the bearing of Alltir from Gwyndir? So from Gwyndir means that's where you're standing with your measurer, and for bearings you need to remember we're turning clockwise from north. So it's asking you what angle is that. Okay? Now the total turn is 360 degrees. So what you're doing is finding out the gap, the other side of that angle. So you're doing 360, take away 110, using whatever method you're happy with for subtraction. So 0 from 0 is 0. 7 from 6 you can't do, so you borrow, and rather than writing it as 360, you're going to write it as 216.0. 7 from 16 is 9, and 1 from 2 is 1. So that angle there is 190 degrees. Then we're on to part B. What is the bearing of Cum from Alltir? Cum from Alltir means you're standing at Alltir and you want to work out that distance all the way around. Now, we're working with parallel lines. So with parallel lines, you've got two common properties. One is the Z angle, okay, which is there, which means whatever that angle there is, that's the same. That's on a straight line, so I can take that away from 180, and it'll tell me what that one is. The other property of a parallel line which you could use is these inside angles that are together inside also add up to 180. So it doesn't matter whether you say, well, if that's 152, you take that away, or you say that's on a straight line, work out what that is, 28, and if that's 28, that's 28 in there. But 28 isn't the right answer, even though it's in the list. I don't want that angle, I want the reflex angle, the other angle that's there. So I've now got to take that away from 360, using whatever method works for you. So it's 332 degrees. So 1 mark for that, 1 mark for that. Just a little bit of revision on bearings, and that should be an easy question for you. C. The area of land covered by the 3 villages is 200 square kilometres. The total population of the 3 villages is 8,400 people. Now in maths we don't often talk about this, so those of you who do GCSE geography will probably have a head start on this because you talk about population density more often. So the population density, they're giving you the clue for the non-geographers in that sentence there. Give your answer in population slash km squared. Population, the slash is like a divide. So that's population is 8,400 over km squared, the area. You can knock out 2 noughts, so you're doing 84 divided by 2, which is 48. And then the second part of that, which question is this? 10. It's 42. Yes. 42, not 48. And then the second part of that is a ratio question. So I've got Cum, Alltir, Gwyndir, 3, 4, 5. So get that down, and then we look at what they're telling us. So the populations of Cum, Alltir and Gwyndir are in the ratio of 3 to 4 to 5. Back up here, they're telling me what the total population is. So they've got to add up the total population to 8,400. So this is a ratio question where I can't put that 8,400 under any particular part because it's the total. So I've got to work out what the total number of parts are, which is 12. So each part, I've got to divide now 8,400 by 12. And 12 goes into 84 exactly. 7 times. 11 sevens are 77, 12 sevens are 84. So each part is 700. And I want the population of Gwynd here, which is that one. So I'm going to times that by 700. 5 sevens are 35. So the population of Gwynd here is going to be 3,500. If they wanted all of them, we would do 3 times 700 to get Cum, and 4 times 700 to get Astir. The marks for those two, 1 mark there for dividing it correctly, and 1 mark for the answer. So I would have got 1 out of 2 there, because I messed up the division. And for this, 1 mark for getting the 700 by doing 8,400 divided by 12, and 1 mark for that answer. Question 11. Kingsley invests £3,000 in an account that pays 2% compound interest per annum. He does not make any further payments into his account. He does not withdraw any money from his account. How much will he have in his account after 2 years? So yesterday we did a paper 2 where we were allowed to use a calculator, and we had a line of maths with powers and multipliers that did that for us. When it's on a paper 1, it's a more straightforward thing to do, but it's boring because we've got lots of steps. But we've just got 2 years here. So £3,000 goes into the bank account. At the end of the first year, so at the end of year 1, they're going to have £3,000 plus 2% of £3,000. Well, 1% of £3,000 is 300, so 2% is going to be 600. So at the end of that first year, they've got 3,600 in their bank. Okay, I'll just do that down here in case you're not sure. So 1% of 3,000, we divide by 10, so it's 300. So 2% will be double that, 600. So that's where that 600 came from. At the end of year 2, we're going to have another 2% paid, but the 2% is now going to be paid on what's in the bank, which isn't what they started with. It's this much. So we got 3,600 plus another 2%. So 1% of 3,600 would be 360 divided by 10. Double that would be 720. So to work out how much he's got in his account after 2 years, I've now got to add those together, which you can do in your head. If you're John, if you're normal, 4,320. I went wrong on that one as well. Yeah, I got completely wrong on that one, because 1% of 3,000 isn't 300. 10% is 3,000. So let's start that one again. 1% is 30. 2% is 60. So at the end of year 1, they've got 3,000 plus 60, which is 3,060 pounds. At end of Y2, they've got 3,060, So now I want to do 1% of 3060, which is £30.60, and 2% we double it, which would be £71, no it won't, £61.20. So what I've actually got to add is 3060 plus £61.20, which is 3121.20. So I made a great mistake there of finding 10%, not 1%. So marks for that. 1 mark for the 3060. 1 mark for the next method, which is taking it to the next year, and 1 mark for the final correct answer. So don't muddle up your 10% and your 1%. This is another type of question that comes up more often on the paper too, reverse percentages. Okay? If you can't remember this, go back to your notes from November when we were doing percentage change, and everything's in there. Kingsley buys a portable Bluetooth speaker. The speaker has been reduced by 20% in the sale. He pays £72 for the speaker in the sale. So that's after it's been reduced by 20%, not before. So he pays 80% of the original amount. And we know that that is going to be £72. What we want to work out is what 100% is to get the original amount. So the easiest way to do that is to first of all find 10%. Now when we find 10%, we're not going to divide by 10 because I've got 80%. So I'm going to divide that by 8 to give me 10%. And if I divide that by 8, I've got to divide that by 8 as well. So 72 divided by 8 is 9. So 10% of the original is £9. I want to find out what 100% is. I want to find out what the original is. So I need to times by 10. So the original value was £90. Okay, and you can check that's right, because if you find 10% of 90 you get 9, so 20 is 18. Take £18 off that, you get 72. So you know you're right. So there's 1 mark there for your method and 1 mark for the final answer. Okay, so there's only a couple more questions to go. Question 12. This is another one of those questions, just like the last one, where if it looks too easy, it probably is. You're probably oversimplifying it. The trigger with this, and they've even put it in bold here with these questions, is that they're being rounded correct to the nearest centimetre. So it's an error bounds question. Michelle owns a cafe. She stacks coffee mugs as shown in the diagram below. She measures the height of each coffee mug as 12 centimetres, correct to the nearest centimetre. So it could measure more than that, it could measure less than that. Each stacked coffee mug creates 4 centimetres extra height, correct to the nearest centimetre. So the first one, you see the full height, and then each one on top of that, you only see 4 centimetres of. Michelle knows that the vertical height between 2 shelves is exactly 39 centimetres. So that's exact, it isn't rounded. Can Michelle be certain that she would be able to stack 7 mugs between the shelves? So, let's go back to the information we're given. It's usually easier to write this on the measurements. If the 4 centimetres has been measured correct to the nearest centimetre, it could be anything up to 4.5 centimetres tall. And it could be anything as small as 3.5 centimetres. Because it's been rounded to 4, any actual value in that range will still round to 4. And similarly with the bottom one, it could be as high as 12 or as low as 11.5. Now the question is saying, can she be sure that she'll be able to replace 7 coffees mugs in that 39 centimetre gap? So we have to consider the worst case. So the worst case is if they're all at their maximum values. Okay, so the maximum values, we're going to have one, the bottom mug, which is going to be 12.5. So worst case if all mugs are actually max. So the first one is going to be 12.5, and then all the others are going to be 4.5, and there's 6 of them. So I got 7 mugs. 1, 2, 3, 4, 5, 6, 7. So that's 9 and 9 and 9. We could have just done this as a multiplication. 3 9s are 27. So I'm going to do 12.5 plus 27, which is 39.5 centimetres. So the worst case scenario is that that stack could be up to 39.5 centimetres tall, which is bigger than her shelf. So she can't be certain because the stack could be up to 39.5 centimetres tall. Okay, it might not be, but we don't know. That is the worst case scenario. So when you see a question like that in the second half of the paper where you think, oh, well, all I've got to do is do 12 plus 6 lots of 4, that's a bit easy. Yeah, it is too easy. Look at the context. And if they're telling you the rounding is measured to a correct, then that's what you've got to do. Okay, so marks for that. There's 1 mark so long as we see that you are working with these maximum or minimum values. So in recognizing that fact, you're going to get yourself a mark. Then there's 2 marks, 2 method marks for realizing you've got 6 mugs at that measure and 1 at that measure, and then a final accuracy answer mark for 39.5 and conclusion. So she can't be certain. Now if you were looking for that, it's an easy question. It's an easy 5 marks. Alright, 1 came up last night on a paper 2. That one's come up tonight on a paper 1. So they come up often. These also come up, as I said to you in class the other day, Cumulative frequency has come up every single paper 1 numeracy so far. So it's really, really worth you doing a bit of revision on this. This year, 50 runners took part in a 5 kilometres race in the Brecon Beacons. All 50 runners finished the race. The cumulative frequency diagram below shows the times taken by the runners to finish the race. What is the modal group? So the modal group has got the most in it, and the way that's shown on a graph is it'll be where it's the steepest. So the modal group is 20 to 25, because that part of the graph is much steeper than any other part. Part B, is it certain that the last runner's finishing time was 45 minutes? You must give a reason for your answer. The answer is no. And the answer is no because if you had the data table that produced this graph, it would be grouped. You've got a 20 to 25 minute group, a 25 to 30 group, and so on. So all you can tell from this graph is that the last finisher was done by 45 minutes, but it doesn't mean they were exactly 45 minutes. So you just want to say no and say because the data is grouped. Part C. The organisers hoped that 80% of the runners would finish the race within 30 minutes. Complete the following two statements. Blank percent finished the race within 30 minutes. Now a cumulative frequency graph shows you less than or within. So if I go to 30 minutes and I read up my graph, and I would be marking this on the exam paper so the examiner can see what I'm doing. I can see there I've got 35 finished within 30 minutes. But I need that as a percentage. And it's out of 50. So 35 out of 50 is the same as 70 out of 100, 70%. So on the graph it's saying 70% of the runners because it's 35 out of 50, which is the same as 70 out of 100. Then to work out what time 80% of the runners finished, I need to find out what 80% is. So I need to find out what 80% of 50 is. Well, 10% is 5, so 80% will be 5 times 8 is 40. So I'm going back to my graph now, and I'm looking for 40 runners. So I'm going up this axis to 40, reading across my graph and down. So 40 of my runners, which is 80% of them, finished the race within 35 minutes. Okay. Last year, the median finish time was 26 minutes. What do they want me to do? How many minutes was the median time better this year? So median is another typical thing that they ask you to find with a cumulative frequency. Median, medium, middle. Where's the middle of 50 runners? 25. So I'm going to go across from 25 and read down really, really carefully using my ruler that John's borrowed. So it takes me to 1 square short of 25. So now I'm going to look at the axis that isn't going to be 24 because this is going up 2 squares is 1 unit. So this year it's 24.5. Is 24.5. Sorry, I'm not showing that. So this year the median is 24.5. Last year median 26. The question is asking how many minutes was it better? So minute and a half. So 1.5 minutes, 1.5 minutes, 1 minute 30 seconds, however you want to call it. This one's easy to mark. There's 1 mark for your explanation of the group data, 1 mark for each of your answers in part C, and in part D, the method of getting your median off the graph and subtracting it to get that answer. And then we're on to the final question on the paper. Box and whiskers, again, come up every year on a non-calculated paper. All right, so if you learn about cumulative frequency, you're halfway to learning about box plots because it's showing the same data. It's showing quartiles. It's splitting the data into quarters. So there are 2 entrances to a stadium, north entrance and south entrance. At each entrance, 3,000 people queued to pass through security. The length of time each of these people spent in the queue is recorded. The box and whisker diagrams show the results. At the north entrance, how many people had to queue for more than 44 minutes? So to remind you about what these bits tell you, that line there tells you the minimum value. So 15 minutes was the minimum amount of time to queue. This whisker tells you the maximum value. So the longest anybody queued was 74 minutes. Then we come to the box. The line inside the box is the median. And then these 2 parts of the boxes are the lower quartile and the upper quartile. So the bigger gap between the whiskers, the more spread out the data. The more central the median, the better spread the data. And each part of this box diagram cuts the 3,000 into quarters. So a quarter of the 3,000 people are in there, a quarter of them are in that bit, a quarter are in that bit, and a quarter of them are in that bit. Back to the question. At the north entrance, how many people had to queue for more than 44 minutes? Well, the 44 minutes is the upper quartile. So it's a quarter of the people have to queue for more than 44 minutes. So what you have to work out there is a quarter, not of 44, of 3,000, sorry. Okay, the whole box represents 3,000 people. A quarter of them queued for more than 44 minutes. So a half of 3,000 is 1,500. And a half of 1,500, half it again, is 750. So 750 people had to queue for more than 44 minutes. What's next? For the south entrance, calculate an estimate of the number of people who had to queue for between 40 and 60 minutes. Remember now, we're at the B grade, the very end of the B grade. We're wobbling between B and A. Okay, so this is part of the nastiest bit of the paper. So I'm looking at the south entrance, and my 40 to 60 minutes is that part. Now, I know that this part has got a quarter of the people in it, because each bit is a quarter. So I know that that part has got a quarter of the people in it, so that actually represents 750 people. And if I look at the bit that I've just coloured in, I can see, oh, that's been divided into thirds. So what I've actually got to find is 2/3 of that 750. So what I've got to work out here is 2/3 of 750. 1/3 I'd be dividing by 3, which is 250. 2 lots of 250 is 500 people. So 500 people had to wait between 40 and 60 minutes. And then finally, at which entrance did the security team seem to be more effective at getting people into the stadium quickly? You must give a reason for your answer. So let's take a look at the upper quartiles. The upper quartile in the north entrance, by the time we reach there, 3/4 of the people are in the ground. So in the north entrance, by 44 minutes, 3/4 of the people were in the ground. The upper quartile for the south, it takes 60 minutes to get to that point. It takes 60 minutes for 3/4 of the people to get in. So the best entrance team is the north entrance. And you must give a reason for your answer. So we can say because 3/4 of the people enter within 44 minutes, compared to 60 minutes in the south. So even though that's the very last question, and that part B in particular was horrible, you should still be able to pick up a couple of marks on that. So long as the testing, you know what a box plot does, you've got a chance. So for 14A, they're looking for the method that you're trying to find a quarter of it, because you know that represents a quarter of the data, and an answer of 750. For part B, there's a method mark for realizing you already know you're working with 750 people, and then finding 2/3 of that to get the answer of 500, and then some form of explaining why the north is better. Okay, so that was intermediate paper 1. We'll do another paper 1 tomorrow, and that'll be the last one before your actual exam. Well done, folks.